Today I'm going to be talking about agentic engineering. The era of coding purely by hand is finally over, which means this actually lowers the barrier for anyone to actually get into program, because aside from the background of computer engineering that most engineers might have today, now essentially you can get started by just speaking out what you want and just talking to the computer and just making things happen, which a lot of people will consider as vibe coding. Vibe coding today has evolved into what we now call agentic engineering. Essentially, if you think about it, this is much more of an engineer actually vibe coding the product. The term vibe coding means you don't actually essentially not looking at the source code, you just pumping the LLM to kind of like generate what you need. And what this actually means for everyone is that anybody can actually create an app from the initial idea to something that you can look at. But eventually you would have to maintain the app. Think of you create something and now there's 100,000, a million people who are trying to use this app. There's going to be different kind of ways that these people are going to use the app that you never anticipated that they would use the app, and this would bring about some kind of bugs that needs to be fixed, some new features that will be requested. Essentially, these not only that the initial creation of the app is actually what you need to do, like there is going to be an ongoing maintenance of the application. If you think about what Facebook used to look like 25 years ago, right? Like it started 2008, and you can compare the amount of features that they have right now to what they currently have right now. I'm not saying anybody is trying to build the next Facebook or anything, but if you think about what actually building an application means, it means this solution, either you're facing personally or somebody else or a group of people, and you feel like this is the best. Like you have a solution and you can talk to your computer and just get something going, and you can demo it to people and they feel like, oh, you know what, this is actually very cool, this is something that I'm going to use day to day. But when you vibe code your way into that, the maintenance is going to overwhelm you as a person, even though if you have like multiple agents that you can work with. And this brings about the term for agentic engineering, which software engineers today have to follow these pattern. I'll call it a pattern, right? Because essentially this changes the traditional way of typing in all the code one after the other. So there are 5 pillars of agentic engineering. One is the context. We will talk about this a lot more deeply, but I would just like to give you like the core 5 pillars that we have to pay attention to. One is the context, as I just mentioned. The second one is validating what the agent actually did. And the third pillar is tooling. And the fourth is the actual code base itself. When we talk about context is best served fresh and condensed. You don't want your agent to be you want your agent to be aware of what was discussed in the meeting, like what is going on in the group chat, like what and why we're trying to like build something, so the agent would know that not only that we're trying to like add this feature, but this is essentially would also lead to some other part of the system that is going to cause breaking changes. So you want the agent to be fully aware of all of these contexts that you're working in. You just don't want to walk in the box. If domain knowledge isn't in the code base, it doesn't exist for the agent. You have to create some kind of document that document all these other things that are outside of the code base such that the agent can understand what is going on and whatever change is trying to introduce. Crappy output ends when agent can self-validate. And this brings us to like the second pillar, which is the validation, right? Like if you have an agent that you're trying to like get this agent to do some kind of task, you can imagine you have some kind of check in place where after every changes that the agent makes, the agent is going to run some validation against those changes, make sure all the unit tests is passing, including the new ones that were added, and also, checking the types and making sure everything compiles and it works as expected, even after the agent has made the change. Humans should no longer be the execution bottleneck. What do I mean by this? When an agent gets stuck, build a tool, give them CLI access to bypass manual steps. I'll showcase this in the demo. You can have every single request, every single change that the agent is trying to do. You can have the agent ask you if you want it to proceed with those changes, which essentially you can just press yes. But at that given point in time, you are already being a bottleneck. It means you're slowing down how fast the agent can run. Most brownfield projects are poison to probabilistic agents. If you think about legacy code, there's no good naming conventions, dead code, competing frameworks, half-finished migrations. I used to work in a project where we have 3 or 4 different kind of state managements in the front end. I'm like, what exactly is happening? Like, all we need to manage is the states for the whole app. But somehow we found ourselves, with 4 different frameworks because somebody who is coming from a React-based project thinks, using Redux is the solution for all any state management that needs to happen in the front end. Somebody else is using Vuex. We have Pena also going on. Like, this is going to confuse the agent a lot. You are not writing code for the next agent, not the you're writing code for the next agent. You're writing code for the next agent, not the human. If you think about it, like going forward, if we have a lot of other engineers using this kind of agentic workflow where they need the agent to be aware of what's going on, be able to like read, pass file, and search through the code base really quickly to find whatever that it needs to put all the pieces together. Everybody has to be aligned with this kind of approach and say, okay, we're not only writing this code for the next person to understand, we're writing this code such that the agent understands how to actually do this. One thing that quickly jumped out to me is people renaming, variables just because they don't like how the agent is naming that variable. If you think about it, the agent is better than naming, variables than anyone. Naming variables has always been hard. So you find some kind of AI agent that can name those variables, and to that agent, there is a reason why it's labeling that variable that name. So you don't really want to confuse the agent. You want to keep everything clean. Get on, leaving comments, step-by-step processes and all of that, such that when the agent is passing the document, the agent can quickly understand, like, this is what is going on in the project even they don't have to spend much more time trying to like figure out what's going on. Compounding engineering is the culminating of team-wide adoption. Compound engineering, essentially, it means every member of the team found some kind of task that is repeated. Probably they have the agent test something out. They can easily create a skill that will be included within the code base such that every other member of the team who is also using this agent can easily use that skill to accomplish the same task. So essentially, the agent is aware of the skills that are available, but then every other team member who probably will benefit from these kind of workflow that you have put together within your own workflows, and it works every single time. You can get every other member of the team to also onboard on this, and that would build up over time, and everybody will end up with a code base that has a list of tools that the agents can use effectively to navigate the code base and even make changes going forward. And at this point, you get to a point where the code begins to build itself. The instruction that the agent needs is within the code base, and all the necessary tools that the agent also needs within the code base. Essentially, you can fire off a cloud-based agent to go into the repo and make changes. Resist the urge to just code it yourself. I've seen a lot of engineers who are fighting themselves, and they feel like, oh, I'm going to get used to this AI so much that I might not necessarily be able to, type in code anymore. Like, we're all humans, right? The first time you learn how to write, how to drive a car, we're learning the basics, right? But right now, most people will probably drive in even beyond their phone, writing a full paragraph text message. This typing in code has become, part of who we are as an engineer. Like, we know when we see a line of code that doesn't look right. So having the urge to type in code will always still be there. You don't want to be fully dependent on AI to help you write stuff. But trust me, this is changing. There's a reason where there's abstraction over lower level language, and you don't necessarily have to learn the lower level language to be able to do, write a full program. I mean, like, the people who call themselves programming, they don't have any understanding of what any lower level language looks like, right? Like, this is just a different abstraction over what we know to be like typing in JavaScript or anything like this to plain English. You just speak whatever you want to the computer and just make it happen. The gap between manual coders and agentic engineer widens every month. If you think about it, I can use sub-agent, one agent to rule them all, and work on a even bigger task. So I'm gonna leave you with the Agentic Engineering cheat sheet. The core 5 pillars that we already talked about. There's context, fresh, condensed, second brain in the repo. There's also validation, self-correction loops, making sure the agent run some kind of test that is put in place after every change is introduced. And truly frictionless CLI, custom skills, MCP, for the agent to fully understand what it needs to do within the code base. The actual code base itself needs to be cleaned out, right? Like, think of laying the foundation for the next level of programming, which is a lot more of an agentic engineering within the code base, you want a very well labeled and code base that is well optimized for agents to understand. And the compounding, which is the fifth kind of like bonus here, would be a shared repo, team-wide flywheel. Essentially, this means everybody contribute to the skill, the documents, the knowledge that lives within the code base itself, and the agent can always use those to make the changes that is required. I hope this is very helpful. I know I was rushing through this really quickly, but I would like to even go deep dive into what this looks like in practical, how you can actually get into Copilot or Cloud Code and get things rolling. I'll see you guys in the next